So in this video, we're going to be looking at reflecting or translating exponential graphs. So what do we mean by that? So let's just try to show an example. So now we have y is equals to 2 to the power of x, right? That's our example. So we're going to plot that graph. We know that it obviously intercepts at 1, and it's going to intercept somewhere at 1. It's going to look something like this. And obviously we'll be increasing exponentially, going down but never touching the x-axis, right? The the x-axis actually. So from here, what happens if we change the graph and say it's no longer that? We say it's y is equals to 2 to the power of negative x. 2 to the power of negative x, right? So our graph will obviously change the value. If we add x here, now we're gonna have 2 to the power. If we add 1 to x, now we're gonna have our 2 to the power of negative 1, which is equals to obviously 1 over 2, right? So as you see, the more we add the value of x, or as the value of x increases, our value of y will obviously decrease. Because if we add 0 to x, it will be 2 to the power of negative 0, which is equals to 1. So, and 1 is obviously greater than a half. So how will our graph look? Our graph will look something like this. Let me just use a different color. Our graph will obviously look something like this. So it will be decreasing. Sorry, it was not supposed to intersect the y-axis, but it will be decreasing. So now our graph changes. So this type of reflection, we say our reflection is it's a reflection along the y-axis. As you can see, they're basically reflecting along this line, which is our y-axis. They're reflecting along this line, which is our y-axis. So this type of reflection is known as reflection along the y-axis. So now we're going to look at reflection along the x-axis, right? So our example is still going to be saying we have a graph which says 2 to the power of x. Now we're changing it. We're saying y is equals to negative 2 to the power of x. So what happens to our graph? So when we draw our graph, which is this one, 2 to the power of x, we know we're going to draw it like this, where it's going to intercept at 1 and obviously continue going up. What about this one though? What about this one? So now if we add 1 to x, we know our value will be negative 2, right? Our value will be negative 2. Our value of y will obviously be negative 2. Negative 2. And if we add 2, our value will be negative 4. So we know that when we increase the value of x, our graph obviously further decreases. So our graph will look something like this. Intercept at 1, and then it will obviously continue going down. It will obviously continue going down. So that is called reflection along the x-axis. As you can see, these two graphs are basically identical. They're just reflecting along they're not identical, I'm sorry. They're basically similar. They're reflecting along the x-axis. Whereas with the previous one, it was obviously reflecting along the y-axis. So that's basically what reflection along the x-axis and the y-axis is. Right? In order for us to reflect our graph along the y-axis, we basically just change the value of x. So now it's not going to be x anymore, it's going to be negative x. So that's us reflecting along the y-axis. And then with this one, we are basically reflecting along the x-axis. So those are the two types of reflections that I wanted us to talk about in this video. So please, if you enjoyed this video, like, share, and subscribe. Tell your friends about it so that they learn about reflections as well. Blah, blah, blah. See you in the next video.